Okay, Trig class, this is the second half of 10.6 video. We're going to start diving into some story problems here where you have two vectors that you are having to kind of add together. Um, but so let's just start. So an object at the origin is acted upon by two forces. So a lot of times they'll start by saying like, okay, maybe you have a tug of war and somebody's pulling, or like maybe this is a tree stump that somebody's pulling out in this direction and somebody's pulling out in this direction, okay? And what's going to actually happen to that tree stump or whatever as soon as it comes out of the ground is it's going to come flying out of the ground at a stronger force. Each one of these vectors is labeling force. So at a stronger force because it's a longer vector, but it's going to come out between those two. And a lot of times they'll do that so that if you would just pull in this direction and have two people pulling in this direction, well, that tree stump, as soon as it comes out, it's going to land and smack you in the head. But if you have one pulling this way and one pulling this way, then it's gonna, when it flies out, it's gonna fly out in between you two, and it's not going to, like hurt anybody. So a lot of times they'll have you do that. So we have a 150-pound force at a 20-degree angle. So this person's pulling out at a force of 150 pounds, okay? And then this force here is 70-degree angle, and they are pulling with 100 pounds of force. So this is the wimpy guy over here. 100 pounds of force and 150 pounds of force. We have to figure out what the force will be, and we have to figure out what the angle will be. So it's going to be some angle between 20 and 70, obviously, but we've got to figure out what that angle is. So what we're going to first do is find the component form of our two vectors, okay? So we've got our first vector, and we've got our second vector, okay? And then we're going to end up adding those vectors together, and then we're going to solve for this guy here, okay? So the first one is 150 pounds. That's the magnitude. Magnitude is 150, and the direction is a 20-degree angle, okay? Magnitude, direction. This one's magnitude is 100 pounds of force at a direction of 70 degrees, okay? All right, and then, like what we did in the last section, your magnitude direction to go to component form is kind of like that polar form that we did. So r cosine of theta plus I sine theta. Cosine is always going to be your x-coordinate. Sine is always going to be your y-coordinate. That's kind of how they have you do it that way. But your r in this case, so for the first one, your r is going to be a magnitude of 150, and your angle is 20 degrees. So it'd be 150 cosine of 20 plus I times sine of 20. And then I would distribute those guys through and find my component form. Okay, same thing for this one. So let's go ahead and do that real quick. Okay, so the components, I have 150 cosine 20. Make sure you're still in degrees on your calculator. So 140 point, do I want to go 2 decimals? Yeah, we'll go 2 decimals, 95, okay? And then I'm going to do sine. I can actually just go back up into my equation and switch this to sine if I want to. And I'm going to do that. So 150 sine of 20 is going to be an upward force of 51.30, okay? That's what he will look like, all right? If we do the same thing for the other one, my magnitude is now 100, but my direction is 70. So I'm going to go 100 cosine of 70, okay, just to make this a little shorter. That is going to be a force of 34.20. And if I do sine instead, that will be 93.97, okay? So that's basically what each one of these is. Like this first one is 140 units to the right and 51 units up. This other one is 34 units to the right and 93 units up, okay? Now, if we combine those two, or add those two together, we'll get a resultant vector, okay, which is going to look something like this. If I add the two components, so it would be like adding the x's together, 140.95 plus 34.2, and that gives me 175.15, and the second one, 51.3 plus 93.97, and that gives me 145 Okay, so if I just think about what this guy looks like, this vector here, okay, this long vector right here, where he will end up is 175.15 units to the right and 145.27 units up. That's what he will look like. Okay. And then I need to figure out what the length of this vector is. Well, I can just do the Pythagorean theorem with both of those, right? This guy squared plus this guy squared is this guy, is my c squared, okay? And that's going to, if I do this, 175.15 squared plus 145.27 squared, okay? That is, I might have to plug my thing in, 51,780, but I want to take the square root of that. Okay, so I'm going to do the square root of the answer. And that means that the force here is going to be 227.55 pounds of force. Okay, so that's my magnitude. That's how big the force is. Okay, then I need to figure out what the direction is there. Okay, hold on just a second. I just don't want it to die on us here. Okay, so last thing that I need to do is I need to find this angle here. And what I can do to find that, if I know the opposite and the adjacent, is just take the inverse tangent, okay? So I have tangent of my angle is opposite 145.27 over the adjacent side 175.15, and then I would do the inverse tangent. Inverse tangent of that, and that will give me an angle of 39.7 degrees, let's say. Okay, 39.7 degrees. So those are the two things that I need. I have that if somebody's pulling this direction and somebody's pulling this direction, what's going to happen is their forces are going to combine to make a greater force of 227.55 pounds at an angle of about 40 degrees, okay? And that's where he will end up, okay? Let's do example 6, okay? A 200-pound box lies on a ramp that makes an angle of 24 degrees with the horizontal. So they've labeled 24 degrees here, okay? If it is a 200-pound box, that means that 200 pounds of force is being pulled upon it in the vertical direction. So this vector here is going to be 200 pounds of force. So 200 pounds. A rope is tied to the box to form a post at the top of the ramp to keep it in position. So this guy right here, they want to know, ignoring friction, how much force is being exerted on the rope. Okay, so basically how much weight does it feel like that rope is supporting, right? Okay, because he's inclined a little bit. He's not going to be supporting all 200 pounds. If it was a rope that was being tied here and the box was here and the box was like suspended, straight up in the air, you betcha that rope is holding 200 pounds of weight. But since he's on a ramp here, he's not supporting all 200 pounds. He's going to be supporting a little bit less than that 200 pounds, okay? So let's kind of look at how we have this thing set up here. If I look at this right triangle, okay, I have that this is a 24 degree angle right here. And I can find out what this angle A is because this is a 90 degrees. I think it's alpha, that angle right there. So if this guy's 24 degrees and this guy's 90 degrees, we can figure out, let's see, 24 plus 90, and I can subtract that from 180. and that will give me a 66-degree angle right here. Okay, so I have this guy as a 66-degree angle, and then what I can do is they're wanting to know what force is being exerted on that rope. Okay, this rope is going to have the same length of force as what, I don't know if you can really see this dotted line right here, but they've made a triangle here, a right triangle there, and they've basically transposed this length to be this length here as well. Okay, so both of those are going to have the same length of force exerted upon them, and they just want to know what the length of this thing is. Okay, so he is sitting here like this. We've just found that this is a 66-degree angle. We're wanting to solve for this, and let me blow my nose. And the one other thing that I know is that this hypotenuse side right here is 200. Okay, where this is my 90-degree angle. So they have a couple right triangles going on here. This first right triangle they slapped in there, and then this second right triangle that we're looking at, we're trying to see what this force will be. Okay. Now notice that this problem does not involve like component form really at all. What we can do is just solve for this guy and get our answer. Okay, so this is more of a triangle, just a right triangle, thinking about force and stuff. And the reason why this works is because it's a right triangle, because we're dealing with 90-degree angles here. Okay, so if this is a 66-degree angle, this is adjacent, this is hypotenuse. Okay, so we're looking at cosine. And we have cosine of 66 is adjacent, which we don't know, over the hypotenuse, which is 200. Okay, and then I would multiply the 200 over. So I have 200 cosine of 66, and that is 81.3. So 81.3, that's this direction, which we said was the same amount of force as this guy is pulling. So 81.3 pounds of force. We said it was going to be less than 200 pounds. So basically that rope has to be strong enough to support 81.3 pounds of force. Okay, if it was a straight up and down again, and that box was suspended in the air, that rope's going to be supporting all 200 pounds of it. But this rope is only supporting 81.3 pounds. Okay. All right. I'm not a big fan of this example 7, so I'm going to go to your homework assignment, and we're going to do one of these together. Let's try doing like number 9. Okay. This is kind of a typical problem that you will see when you're dealing with vectors, because we're talking about planes and wind. Okay. And they made this really easy for you, and I think a lot of the rest of these are the same way, because they're saying an airplane is trying to fly due north at 100 meters per second. So basically your plane is traveling like at a 90-degree angle or straight up in the air, right, at 100 meters per second. Okay, but the wind is blowing from the west at 30 meters per second. Okay, so basically I have a force that's being pulled like this at 30 meters per second. West. Yes, that's west. 30 meters per second. Okay. So this is kind of like that tree stump problem where we have like the tree stump in the middle and one's being pulled up and one's being pulled to the left. Where is it going to end up going? The plane is going to go this direction, okay? Probably more so in the up direction than it is to the right, because this is only pulling at 30 and this is pulling at 100. So it's probably only going to move a little bit to the right, and it's going to still go in the upward direction, but we need to figure out what that upward direction is, okay? So we need to figure out what the component form of each one of those vectors is. Okay, all right, and I'm going to do the first one in like the way that we've been doing this, and then I'll show you kind of how to cheat in this case. Okay, so 100 is going to be my magnitude, and the direction of this guy, since he's going straight up, is 90 degrees. Okay, so he's a direction of 90 degrees. Okay, this guy's direction will be 180 degrees, okay, and this guy's the magnitude is 30, okay. So remember we do r times cosine theta plus I sine theta, okay, and in this case our r is going to be 100 and our theta is going to be 90 degrees, okay. So for this component form, I'm going to take 100, let's 100 times cosine of 90. Okay, cosine of 90 is 0 times 100 is still going to be 0. So this is the point 0, comma. I'm going to do 100 times sine of 90 degrees. Sine of 90 is 1, and 1 times 100 is 100. Okay, so if you have to write the formula out, you can sure do that. Okay, but 0, 100 is basically where this vector is going to land me. 0, 100 is going to get me to that point, which we could have probably just figured out by like thinking about it, right? If it's going 100 straight up in the air, that's component form of 0, 100, right? Okay, so let's just think about this second one rather than doing the formula. If I'm going 30 to the left, that's going to be the coordinates of negative 30, comma, 0, right? If I would do 30 times cosine of 180, that would give me negative 30. If I would do 30 times sine of 180, it would give me 0. Now I'm combining those two things together, and what it's going to happen is negative 30, comma 100, right? Because 0 and a negative 30 is negative 30. 100 plus 0 is going to be 100. And then they want to know what the plane's resultant velocity is. So they want to know what the length of this guy is, where he's going to end up. He's going to end up going 30 units to the left and 100 units up, okay? So negative 30, 100, they want to know how long this vector is, okay? So I can just do the Pythagorean theorem with that thing, okay? So I would do c squared equals negative 30 squared plus 100 squared. And to get just c, I would take the square root of that. Okay. So negative 30 squared plus 100 squared. And I'm going to take the square root of that answer. Shoot, I bet it's not going to square root of that answer. 104.4. Yep, I bet that's about right. Okay. So 104.4. And that is meters per second, okay? That's going to be the velocity that I'm traveling, okay, in this way, okay? Now, they did not ask for the direction that I'm going, right? But I can figure that out, this angle right here, I can figure that out by doing inverse tangent. So tangent of that angle is going to be opposite 100 over negative 30. That's what he will look like. Okay, so if we continue to do that, inverse tangent of 100 divided by negative 30 is going to be a negative 73 degrees. So this one is right here is a negative 73.3 degrees, which actually, if we go from standard position on over, will be 180 minus 73.3 degrees, which is 106.7 degrees from here all the way over. Okay, so 106.7, we didn't need to find that, but that's just kind of good to know anyway. So 106.7 degrees in standard position from there all the way around. Okay, otherwise my resultant velocity is going to be 104.4. That wind is basically pushing me that direction, which is going to speed me up just a little bit, and it's not a very strong wind, but there we go, okay? What I'm going to have you do for homework then is 7 and 8. You should be able to do, they're going to be very similar to the one that we just did. Go ahead and do 10 and 11, and then I'll have 12 and 13 be bonus, because those are kind of a very lost goose flies in all these directions. What's going to happen, okay? So we'll have 12 and 13 be bonus, but the other 4 you should be able to do based on the one that we just did, okay?